In this video, we're going to work towards solving more complex equations still, equations that have fractions and decimals in them specifically. And to make that job a little bit easier, I'm going to start with three very basic equations. And I'm just going to solve them quickly here. So subtract 2 on both sides with this one, x equals 3. The next one, I have to subtract 4, so I get 2x equals 6. Divide both sides by 2, and so I get x equals 3. Okay? And in the last equation, I minus 400 on both sides, which is going to give me 600 equals 200x. Divide both sides by 200, and so x equals 3. And you'll notice that all three equations solve to the same thing. And is that just coincidental, or is there something else going on here, you might say? And if you looked at all three equations, you might have noticed something else going on here. To go from the first equation to the second equation, what I've done is multiplied both sides of the equation by 2 to get the second equation. And to go from the first equation to the third, I've multiplied both sides by 200. And these are what we call equivalent equations. If you multiply both sides of a given equation by a common number other than 0, you're going to get a different looking equation, but you're going to get an equation that solves to the same answer. So what we're saying is, if you're asked to solve this equation and you decide to divide both sides by 200 down to this to make it easier to solve, solving this equation, which is easier to work out, will give the same answer as the more complex looking equation because they are equivalent. Now, the reason I bring that up is because we're going to go into solving equations that have fractions in them. And so I have an example of that here. I could certainly work with fractions. I could subtract 3/4 on both sides. And so that's going to be 0. I'm going to have 2x equals 1/4 minus 3/4, which is negative 2/4, which is negative 1/2. And then I could divide both sides by 2. That looks a little awkward. It just means negative 1/2 divided by 2, which is negative 1/2 multiplied by the reciprocal. And so x would be negative 1/4. Okay, so I've solved the equation. But what I'm going to do now is I'm going to take advantage of what I talked about earlier, equivalent equations, to make this equation even easier to solve. And I'm going to do that by eliminating the fractions. The common denominator of the fractions in this question is 4. That's my lowest common denominator. And what I'm going to do is multiply both sides of this equation by that common denominator. I'm going to multiply both sides of the original equation by 4. And what I'm going to get is a different looking but equivalent equation. An equation that will have the same answer as the original equation. So I've got to distribute the 4 through. So that's going to be 4 times 2x plus 4 times 3/4 equals 4 times 1/4. Okay, so we have a little bit of fraction work to do here. This is 8x. 4 times 3 over 4. I'm just multiplying. So the 4 is 4 over 1. Remember, I can cross reduce. 4 goes into 4 once. And so I'm left in the second term with 3. And 1/4 times 4 over 1. Again, I can cross reduce, and I get 1. So what I have here now is an equivalent equation. This equation is going to solve to the same solution as this equation. But you'll notice that my equation no longer has fractions in it. It's going to be easier to solve. I won't need to work with fractions along the way. So to solve it, minus 3 on both sides. 8x equals 1 minus 3, which is negative 2. Divide both sides by 8. And so x is equal to, let's reduce this to lowest terms, negative 1/4. And sure enough, my solution is the same And so, when you're solving equations with rational coefficients, coefficients with fractions or decimals, I highly recommend that you apply this principle. That is, make your equation easier to solve by eliminating any fractions or decimals in the problem before you solve. And you can do that by multiplying both sides of your original equation by a convenient number. And that convenient number is going to be the common denominator of the fractions, or in the case of decimals, a power of 10. And I'll do an example of both of these. Alright, so here's a slightly more complex equation. And I'll notice that my common denominator amongst the fractions, I only have two fractions here, my common denominator is 6. Okay, this is the magic number. What I'm going to do is take my original equation and multiply both sides. I'm putting it in brackets to show I'm multiplying. Don't use an X for a multiply sign. Use brackets. And now I'm going to distribute 6 to both. Remember, I'm able to do this because if I multiply both sides by the same thing, the equation stays in balance. It's going to provide an equivalent solution. So I'm going to have 6x plus 6 times 2/3 equals 6 times a half minus 6 times 4x. Okay? A little bit of fraction work here, but because I picked the common denominator to multiply by, all of these will cross-reduce nicely. So on this term, I'm going to have 2 times 2, which is 4 over 1, just a nice old 4, 6x. This cross reduces to 3 over 1, or 3, and 24x. Look at that. A nice equation with no fractions, much easier to solve than something that has fractions. And then away we go. Let's get the x's on the left, which means we have to remove the x's on the right. So we've got to counteract the negative 24x by adding 24x to both sides. That would be 30x plus 4 would equal 3. Okay, we have our x's alone on the left. We have to get rid of the constant 4 plus 4. So we minus 4 on both sides to get rid of that. 30x equals 3 minus 4, negative 1. Divide both sides by 30. Therefore, my solution is x equals negative 1/30. Alright, so if I plug that number back into my original equation, it'd be a little bit messy to do, it would balance both sides. Here's an example of an equation involving decimals. I could certainly solve the equation with the decimals, but I could also multiply both sides by a convenient number to eliminate the decimals. I'll notice that I have a 1 decimal number here and a 2 decimal number here. So if I multiply the 2 decimals by 10 to the second power, in other words 100, that should eliminate all decimals in this equation. So let me write my original question out, and I'm going to multiply both sides by 2 powers of 10, in other words by 100. Whatever I do to one side, I do to the other. It keeps it equivalent. 100 times 0.3, that would be 30x, minus 140 equals 4. I now have an equation with no fractions or decimals. Much easier to solve. Add 140 to both sides. Divide both sides by 30. And then reduce your answer to lowest terms if you can. You can divide top and bottom by 2 for sure, 72 over 15. And then I think we can divide top and bottom by 3. 3 goes into 72, doesn't it? Yes, it does. 24 times and 5 times. And so my solution is x equals 24 over 5. Solving equations with rational coefficients can get tricky and messy, but the more you practice, the better you'll get at it. Here's another situation. I have 2/3 times x minus 2. In other words, I have one term here. Since the stuff's all multiplied together, it's one chunk. And similarly here, negative 3/4 times 2x minus 1, that's one chunk. And if I look at my fractions, because I'd like to get rid of those to make this easier to solve, the common denominator amongst all fractions would be 12. And so I'm going to multiply both sides of my original equation. Just write my original equation down again. Just leave a little bit of space because I'm going to multiply both sides by stuff. I'm going to multiply both sides by 12. Alright. Now you need to be careful here because the 12 will not distribute to both parts because this is all one term. It's all one chunk. You're going 12 times 2/3 times the bracket. Whenever you multiply three numbers, you multiply, let's just say you had 2 times 3 times 4, you always multiply two of them first and then take that answer and multiply the last. You don't go 2 times 3 and 2 times 4. Alright? So that can be a little bit tricky for people. So we're multiplying both sides by 12, which is 12 over 1. And let's multiply the 12 by the 2/3 first. So that can cross reduce. 3 goes into 3 once, into 12 4 times. Over here, 4 goes into 4 once, into 12 3 times. And then what I'm left with is 4 times 2, 8 times x minus 2, because the 8's over 1. And over here I'm left with 3 times negative 3, negative 9, times 2x minus 1. So we're going to go through and do that. I'm just going to do this quickly because we've already talked about solving equations with variables on both sides. I'm going to put my variables on the left. 25, divide both sides by 26. Therefore, my solution is x equals 25 over 26. Alright, let's solve one more monster problem. And we have one chunk separated by a minus sign, 2 terms, 3 terms, 4 terms here. And so my lowest common denominator amongst all my fractions, I have to identify that because I want to multiply both sides by a number that will eliminate fractions. The magic number is going to be 12. So I'm going to multiply both sides of the equation by 12. Alright. There's 2 terms, so we distribute to both terms. So that's going to be 12 times x minus 3 over 2 minus 12 times 1/3 equals 12 times x plus 1 over 4 minus 12 times 1. Alright, and these 12s are all over 1 because they're fractions, right? Just a reminder that when I multiply, I cross reduce. So let's take care of the cross reducing. 2 goes into 2 once, into 12 6 times. 3 goes into 3 once, into 12 4 times. 4 goes into 4 once, into 12 3 times. And there we go. Okay, you'll notice that on the denominators I've got 1s. In other words, my fractions are going to be gone. So my next step is going to be 6 times x minus 3. I'm just going to write it out like this. Don't want to do too much at once so I don't make mistakes. 3 times x plus 1 minus 12. There is my equation without fractions. Okay, so let's solve it. 6x minus 18 minus 4, 3x plus 3 minus 12. I want to collect like terms on each side, so that would be minus 22. Collect like terms on both sides, that would be negative 9. Let's put our x's on the left, subtract 3x. So that'll be 3x minus 22 equals negative 9. Let's move the negative 22 off the left, so we'll add 22. So that means that 3x is equal to 13. Divide both sides by 3, and therefore x is 13 over 3.